So in this video, I'm going to explain problem of these code forces around 911 ready for division 2. So in this video, I'm going to explain the first three problem of this problem set. So let's now begin with problem A. So the name of the problem is covering water. So what problem said that we will be given some number of tanks, right? Some number of tanks. Okay. And there is property that each of my tank is initially empty, which means there is no water in any of the tank. And they have also said in between these consecutive tanks there are some block tanks, which means I cannot fill any water in this cell, and they are not empty also, which means I have to do nothing with them. Okay, and there are also some water tank here also, then here also, and this is also empty block here. So what problem said we have to fill all the empty tanks with water. And they have defined two operations from to us. And what is operation number one? Operation one defined as that I can take any empty cell and fill it with water. Okay, I will fill it with water. And second operation said I can take water from any filled tank and place it in any empty cell. Okay, this is operation number two. And they have given a property of this water tanks. But they have said that if there are three consecutive water tank present and there is water in left one and right one also, then the middle one get filled with water. Okay, if which means if there is a tank empty and its left one and its right one contain water, then the middle one will automatically get filled by water. So I have to tell them what is the minimum number of operation one I can use to fill all these water tanks. Okay, so this is the problem question. So I will tell you the pretty much simple code of this or solution of this. So first of all, tell me what is the minimum number of operation one you can use to fill all the three consecutive tanks. So the minimum operation is two only, because you see you will first fill this one and then fill this one, and you can see this middle one get filled by these two one. Okay, which means the minimum number of moves to fill water in three consecutive tanks is two only. So now let's begin to the next part. So if I am having many number of tanks, if I am having many number of tanks, how can I fill that also? If I am having three consecutive tanks once here, and there are some more tanks out there, so how can I fill them? So you can see if I fill these two tanks with water, then this middle one gets automatically filled, which means this also contain a water. And according to operation number two, I can empty any filled tank and replace the water in any empty cell, which means I will move the water from this tank and place it here. Okay. So you see, this tank is again empty, and its left part and right part is already filled with water. Then this again get filled with water. Instead, I have once placed water from this tank to this tank, but also this tank will also get filled by these two one, which means I can again use the same operation. Which means now I will take water from this tank and place it here. Okay, right? Then also, which means this tank is now again empty, but this right and left are already filled with water, which means this automatically get filled with water with next operation, which means to if which means I will use only two operation to make this string all the filled with water. So there is one operation, right? So which means if any point I will be having any number of, which means if any point I am having three consecutive empty tanks, that means in that string I can only use two number of operation to make all my to make all my empty tanks fill only. Okay, but if there are no three consecutive empty tanks in my string, which means there's only one configuration left, which means there is one empty tank here, or there is a block, there is a oh, I will erase this part. So if I do not have any two three consecutive empty cells, which means I am left with two configuration only. If I am having a this configuration like this, and this is a block one, and this is an empty one, right? So which means I have two consecutive empty tanks and one consecutive empty tanks. So I can simply use one operation to fill all these tanks, and simply print the answer. Which means if at any point I'm having three consecutive empty tanks, I will simply use two operation only to fill all my string. But if there is no three consecutive empty tanks, simply I will count the number of empty tanks in the string and simply print the answer. So if I show the code is pretty much easy. So here you can see. First of all, what I'm doing, I'm simply counting the consecutive empty tanks. If at any point my consecutive tanks is greater than or equal to 3, I will simply print 2 and return. Else, I will simply increase the count by the number of empty tags, which is either 2 or 1 only. So at that I will print the count and return. So this is a whole permutation of problem number 1. So now let's begin to problem number B. So this is problem B, right? So what problem is said that we will be given some numbers of 1 and 2 and 3, which means we will be having A numbers of 1, B number of 2 and 3 number of C. So what problem said that if we having 2, we will be having some number of ones in our array. Or what they have done, in one operation I can choose any two indexes from that array. Either it will be 1 1, either it will be 2 2 or 3 3, or there can be combination also. Like I can pick 1 2, I can pick 2 3, or I can pick 3 and 1 also. But what they have said, if I'm picking the array, if I'm picking the two elements are like 1 1, I will remove both of the ones from that array and simply add another number in my array such that my that number is not equal to neither of the removed array elements. Which means if I am removing one and one from my array, I can either add one single two at then, or I can add single three at then. Similarly, if I am removing one and two from my array, I can simply add three only at my end of the array. So I have to tell them either if it possible to make all the numbers in my array to 1 or 2 or to 3, which means I have to tell, for example, in this case you can see, um, I will tell it here only. So according to first test case, I am having single 1, single 2 and single 3. 1, 2, 3. So if I choose these two elements, these two elements, I will simply remove them and simply add one at the end. Okay. So you can see in my final array, they could only contain ones only, which means I can make one, I can make all the elements equal to one. Okay. But if I'm having like this, but if I'm removing these two elements, then these 12 elements will be removed and I will simply add 3 at that, which means my arrays can also contain 3 only. Similar fashion, my 2 can also my array can also contain 2 also, which means all the 3 elements can be possibly remain at the end of the array. So you can see it answer of this problem is 1 1 1. 1 represent I can make all the ones, and this one represent I can make all the twos, and this represent I can make all the threes. Okay, so how to approach this problem? So if I tell you, if I am having certain number of 1 and 2s in my array, for example, there are some number of 1, some number of 2, and some number of 3 in my array, right? Okay. And there also 1, there is also 2, right? So you tell me, can I make all the elements equal to 1 in this array? So answer is yes. Why so? Because you see, if I have to add another one in my array, I cannot choose this one. I cannot choose this one from in my any of the operation. Because you see, if I choose one and two, I cannot add one at the end. Because you see, one of the element is one only, so I can only add three at the end, which I did not want. I want all the elements equal to one only. So what is a possible move? So I can only choose a pair of 2 comma 2, or I can choose a pair of 2 comma 3 either. So in both of these operations, I will always add one at the end. Greedily, we can say. So you can see, if I'm choosing these two, so I will simply add one at the end and remove this part. So if I'm choosing these two and these two and these three, I will simply add one at the end and simply remove this part. Okay. So you can see, I can also say next step I can choose. Next step I can also choose these two. Next step I can choose these two. Right. So in similar fashion, I will add two ones at the end. And here you can see, at the end of the array, I'm only remained with 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 number of ones. And there is no 2 and no 3 in my final array. Which means I can make all the elements equal to 1. So, but you will see, there is a one catch here. You can see, I will never mm, change my one's occurrence to make all the elements to equal to 1. Okay. Which means I have to deal with occurrences of 2 and 3 only to make all the elements equal to 1. And how to deal with the occurrence of 2 and 3? So you can see, I need at least two pair to add one more one. Which means there should be number 2, 2 to add 1, or there should be number 2, 3 to add 1, or there should be number 3, comma 3 to add 1, which means in any of the operation I need at least two numbers, right? So you see, if I'm having a even number of, if I'm having an even number of twos and threes, total. So if the total count of twos and threes is a even number, it means at every point I can make a pair and convert that pair to one only. Okay. So you can see there are total number of 1, 2, 3, 4, 5, 6, 7, 8. So the count of twos and threes is equal to 8, which means I can make four pairs out of these eight numbers, and these four pair will individually generate four ones. Okay, you can see by utilizing this all the eight twos and threes, I will add four ones in my array, and the remaining one will also count. And by doing this, my all the elements in the array become one only. In the similar fashion, if my array contain a single two and some number of three, some number of two, and you but you see in this case I cannot make my all the elements equal to two. Why so? Because you see, to make all the elements equal to 2, I will never change my occurrence of 2. Because you see, if I took 2 in any of the pair, I cannot make all the, I cannot generate another 2 from that pair. Which means I have to either choose 1, 1, 3, 3 or 1, comma 3 to add 2, 2 or 2 in my array. Which means there should be at least 2 ones or 1 and 3 or 2 and 3 in my array. So which means you can see there are total number 1, 2, 3, 4, 5, 6, 7, 8, 6, 7. So there are total 7 number of ones and threes in my array. Which means if I try to make a pair, like I have make this pair, now try to make this pair, now try to make this pair. So all of this pair will generate 2 only. Okay. But you see there is one 3 left. You can see there is one 3 left. Oh, so what will the my array look like after these three operations? My array will be look like these two are already there. This one will produce one, another one, and another three. So you can see how now can I make my all the elements equal to two? I cannot make, because you see the single operation left is two and three only. But if I choose two and three, this will generate one only. This will generate one only, which means I cannot never make my all the elements equal to. So simple catch is there. So if I want to make all the elements equal to 2, the sums of total, the sum of 1, the sum of count of 1 and 3 should be even number only. So why so even? Because I can make pairs, and each and every pair will generate 2 only. So the problem lies, so the now the solution lies down to this only. If I want to make all the elements equal to 1, then the count of 2 and 3 should be even. If I want to make all the elements equal to 2, then the count of 1 and 3 should be even. If I want to make all the elements equal to 3, then the count of 1 plus 2 should be equal to even only. So if I show you the code is also easy. Here you can see I am simply calculating the, if I want to make all the elements equal to 1, then the count of 2 and 3 should be even number. Then I will print 1, else I will print 0. So similarly, if I want to check for 2 and 3 also. So this is the problem intuition. I think so. This is pretty much easy problem according to div to B level. So now let's become to the last problem I was able to solve in this problem set, which is problem C. So you can see the problem C is also easy problem in according to level of div 3, div 2, C question. So the name of the question is Anji's binary tree. So what they have said, I have tell you here only. So this is also easy problem if you note please. You can see if you know implementation interest, then this question is hardly 2 or 3 minute question and 5 minute coding only. So you can see if I'm having a if I'm having a binary tree only, right? It is not a graph tree, it is a binary tree, which means every node will contain at most two number of childs, right? So each and every node is assigned with a value. Either it will be either it will be u, L or R. So this represents if this element is equal to U, which means if I'm standing at this position, then I will move to the upper part. Okay. And what is left means? Left means if my current index is left and I am at this index, then I will simply go left of the array. And similarly, right means I can go to the right of the array from the current index. So I have to tell them what is the minimum number of changes I can do. But changes is like this. If this element is U, then I can change it like I can change it to L or R. So or R, right? So I have to tell them what is the minimum number of changes I can make so that I can reach from top of vertex to my any of the leaf. So this is the whole problem only. So maybe most of you should be able to solve this problem from this only. So let's debug now some test cases. So you can see this is the first step. So, I will remove this only. So you see, my first test case is like this. I am having a vertex one here, and you see where vertex one is always the root of my tree. This is given to us. So I am having three nodes like 1, 2, and 3. My first node represent L, and second node represent R, and third node represent U. So if I am standing at this position, so I will always start from root index only. So if I am at here only, so where I can go? So this the value of this represent I can go to left. So let's see, I will go to left. If I'm going to left, you see I am at the leaf of the tree, which means there is zero number of operation required to reach from left to read from vertex to right part. But if in this case, if this is not equal to instead it is equal to u. So you see, if I'm at a vertex one, so I can only go up, right? But I can only go up. But you see, I can only go up. But you see, uh, but there is no chance. But I can only go up. So in this case, I will change the operation. I will make it as L or R. I will make any of them, which is my choice only. Because you see, both of the L and R are leaf node only. So I will make it to R only. So let's see, I have make it to R. So similarly, if I am making it to R, I will go to this position. I am at an and then I am at a leaf node. So you can see I am using at most one operation to reach at the leaf node from vertex. Okay. So maybe now you have got some idea how to solve this problem. So if you haven't, I will tell you. So there I will debug one more test case. You can see the answer is three only. Yes, this is the test case which you will get, which will give you more understanding. So initially there is a zero index. So the left part is 3. Okay. And the left part of 3 is 0 comma and here it is 4. Okay. The and the right part of 4 is 2 only. Okay. And what are the values? It containing R, my 3 containing L, my 4 containing R, and my 2 containing U. So now tell me, if I want to go from this index to this index, how many things I have to do? So you see, this index is initially representing that I can go in this direction, but there is no vertex here. So which means I have to change this R to L only. Okay, one operation done. So if I'm changing to L only, I will go to this direction. Okay, after I change this direction, this is telling me you should go to the left, but there is no load at the left, which means I have the only option I have left with this go to right only. But this saying go to left, so I will change it. I will make it to right, which means one more operation. So then I will go to right part. Okay. So now this is saying go to right, but there is no right part and only left part. So you see, if I want to go to right part or left part, I will make it to left, which means one more operation required. Okay. After going to this direction, you see, I'm at the leaf node. If I'm at the leaf node, which means the minimum number of steps which are required is three only. Okay. So now how to solve this approach or how to approach this problem? So you can use a normal BFS to solve this problem. So if I make a random tree like this, wait a minute, to make a random tree, you can skip this part, right? So this is a random tree here. So if I'm standing at this position and I want to reach either this, and I want to reach either this part, either this node, this node, or this and this and this, because they all are leaf node. Okay. So what I will do, I will simply run a BFS from my vertex 0 or root vertex to all the leaf nodes. So initially you will see there will be some of the value assigned to them. Either it will be L, R, or U. Okay. So you see, I will simply check. while going to next. So you see I am at this position. So I will go, you can see the what how does the BFS work like. BFS symbol, first of all you go to this level, then at this level, then at this level, then at this level, then at last level. So this is how my BFS works. Okay, so if I am starting at this level, so if I want to go to the left part, so if I want to go to left part, then I will see what is the current value of this vertex. So let's say the current value of this vertex is R. So but if I want to go to left part, I will check whether my vertex, whether the value of my current vertex is left or right or U, which means, if you can see, which means in this case it is right, which means it is not equal to left. So in this case I will simply pass on count 1. Okay, and the count represent how many changes I have done to reach at this position. So to reach at this position, I have already used one operation. Okay, but you see, if I want to go to at right position, but you can see the value of this node is already right only. So which means to go at this position only, I will simply pass it here, and the count will remain 0. Which means to reach at this index, I will use only 0 number of operations. Okay, so now let's see the value of this operation is u. So the if the value of this operation is u, which means if I go to go to left or right, I have to change this value. To go to left, I have to change the u to L, and to go to right, I have to change this value u to right only. Which means in both of the part, I will increase my count. So to reach a distance, I will use at most two operation. One operation is required till here, and I will add, because you see to reach it next, I will always require one number of operation, and to go to next and to go ahead from this node, I will always increase the count. So to reach at this index, I will simply increase my count to 1. And to reach this index also, I will always increase my count. So this is also 2 only. So now let's suppose this is again u. So to reach at this index and this index, I have to use a operation. So to use a operation, I will simply increase my count, and these two will become here 3 only, and here also 3 only. Okay, but you see, let's suppose this value is r only. So if this value is r only, so to go from this index to this index, I will never change the value, which means the minimum value to reach as this index is 2. And if I go to from here to here, I have to increase the count, which means I have to make this 2 to 3 only. Okay, so now let's do this part only. So if this is to reach at this position, I will use 0 number of operation. So let's suppose this is equal to r. Okay, so if this is r, but I want to go to right, then to reach at this index, I will use one number of operation, which means I will simply change this r to L. Okay, so now let's suppose this is again also r. So now if I want to go from this index to this index, I will use 0 number of operation. So I will simply pass on the count which I have received from the parent to this only. But let's suppose this is equal to u. Okay, now to go from this index to this index, I have to change the operation, which means I have to make this u to r only, which means I have to make this one and pass it to here. Okay, now let's suppose this is also u. If this is also u, I have to reach at this index and this index. I have to always use an operation and make it to 3. So if so you see, I have got all the values, all the minimum values which will be required to reach at the leaf of the node. Now what is the minimum value of them? So minimum value to reach is this vertex. This vertex only require two number of operation to reach it, which means my answer is 2. Okay, but that's the whole problem. So I have to simply return 2 only. So first of all, now I will wrap up the problem. So I will simply use a normal BFS function which will run from root node to all of the leaf node, and simply check the condition LRNU, and by reaching at the leaf node, I will simply check the count which I have received from the above, and simply store the minimum of all these count. So if I show you the code, here it is the code. So first of all, what I'm doing, I'm simply inputting my array, taking my input, and pushing the elements A and B in my corresponding index. And there is a queue for which contain pair int combined, and whose first value is node itself, what is the vertex, and the count 0. Because you see, to reach at the vertex 0, I only require 0 number of operation, because at starting I am at 0 only. at the root only. So what I will do next? I will simply calculate the next node and the distance which is required to reach at this next. Also, you see, if there is no left and no right of the current node, which means it is a leaf node. So if it is a leaf node, then I simply store the minimum of distance in my answer. But you see, if I want to go to left, right? If I want to go to left, and the value of the parent is also left, then I will simply pass the distance. But else if it is either R or U, then I will simply pass the distance plus one to the next part of the root, the next part of the tree. Okay. But if I want to go to right, but the value is right also, then I will simply pass on the distance which I have received from the above. Else it is R or U, then I will simply pass on distance plus one to the next tree. And here you can see if at any point I am at the leaf index, I will simply store the minimum of all the distances which I have received to reach the leaf node and simply print the answer in the end. So this is the whole implementation of problem C. So if you like the video, please don't forget to subscribe my channel. Until then, stay tuned for the next one. Thank you.